Okay, as Gilad already mentioned, my name is Ralph Hagemeier. I'm a product manager in Wix Data Science Engineering, and I'm in charge of the machine learning platform, which is basically the entire pipelining and plumbing around what is being done by the data scientists. What I will tell you about is A, why did we build our own ML platform? What was the motivation? What's our vision, where we want to go, and where we are right now? And then I just will walk you through how easy it is to build, train, and deploy a model to Wix production and use it, and also a short peek on what we're doing with the research environment. So, anybody who attended a lecture on ML Ops probably saw a slide that looks very similar to that. This small part is actually what our data scientists should be busy with and work. The ML code, the algorithmic code. Everything else is my job and my team's job, which is the entire pipelining and engineering around it. And just to see a few of the use cases we have, today Wix has 260 million sites. So, we are building chatbots, we have smart layouting, we have site classification, assigning a category for each of our sites, phishing, spam, fraud, premium prediction, whether one of the sites is likely to become a paying customer, forecasting, and all kinds of recommendation systems, and of course, search, what Leo mentioned in his previous lecture. So, our decision was to build an end-to-end machine learning platform. I mainly go through the UI, but everything that I can do via the UI, of course, with our API-first approach, you also can do via API. Why did we decide to build our own platform? And not just buy something, go out there are plenty of startups. No, there were not, because we started building this 5+ years ago. While today there are plenty of providers, 5 years ago there was almost nothing. And the second thing is, almost all big companies doing data science at this scale, they finally build their own solution. Taking somebody's solutions, a one-size-fits-all solution, and doing customization is extremely painful. And of course, the vision, like I basically showed in that overview, we want data scientists at Wix train, deploy, maintain, and monitor machine learning models without any development effort. My personal vision is that in a year from now, in a couple of years, anybody at Wix can have his own model and manage it. You don't need anything but understanding of data. I'm always thinking if I show this slide, and finally I decide, yes, I am. You can have the best algorithm in the world, you can have Gen AI, and you can have the best data scientists. If you didn't define what you're actually trying to solve, you're going nowhere. It is so important, and the platform cannot help with that. We cannot tell you what is it you're trying to solve. Make sure you understand what you're trying to solve. What is the ideal outcome? What are the KPIs? And how do you know whether you succeeded or failed? Once you have a clear goal, now you can come to our platform and move ahead. Number one, data preparation. Almost as important as understanding what you're trying to solve is the data that you're using for it. If you're using the wrong data, it's garbage in, garbage out. Nothing will happen. So, to prepare training data for the use case I'm walking through, you need two important parts. To create a data set which will finally be used to train, you need a kernel and you need features. What is a kernel? Well, basically it's a table containing the population that you are trying to work on. So the minimum that you need to provide is some entity which usually in Wix is either a site or a user, a timestamp, to say I want the data for this time, and a label. I like examples. I'm always having a hard time with theoretic explanations. It's all users who signed up in a certain time frame, and if they became premium users or not, which is the label. And based on that, you now can move to the next step. The next step, choose the right features, talking to an analyst, doing some feature exploration, that you now will add to your kernel. So, for that, we have something called a feature store. And in the feature store, you can define features or you can find or define features which are relevant for your business problem. So we have two types. One are event-based features, which is basically user or site actions. And examples would be, how many times the user saves the site, what is the time between two actions, like for example, sign up and first action, which browser was used for the last login or the first login, or the user accepts a new payment method. And the second part is our site content-based features. And basically, these are features which are extracting from the content of the website itself. They're not based on user actions, but it's like how many words are on the website, how many contacts does this website have, how complete is the website, what are the menus, and like everything you can basically extract from the content of a website. How can they be used? And this is a very important thing. We have the features available for offline use, which is when you're training a data set, and also for batch prediction, offline prediction, which I will elaborate later. And for online, meaning that you want the feature data served in real time. It's so important because basically our platform makes sure that you get exactly the same feature data when you, that you use in your training, also in the online world. There's cost connected to it, and you don't need all features actually for real-time use cases. A lot of things are only good for offline. So our default is offline, and because I like in my UI everything to be available and usable with one click, basically, you have this feature view with some feature name, and then you can publish it, and once you publish this is now available for real-time use cases. Why a feature store in the first place? First, you want to have a standardized way to create features. You want to have a naming convention, you want to prevent duplicates, you want people to reuse the same feature rather than every company. We have a lot of companies in Wix creating their own feature and storing the same data 40 times. And you already can see it, like for example, a feature like how many times a user saved the site is probably good for like plenty of models. It can be used for premium prediction, recommendation, fraud. So reusability is a big thing. I said the goal finally is to create a data set, and as I said before, I really like to keep things simple and short. You go to the UI, you pick the features that you decided are relevant, you go to the next step. All you need to provide is now the metadata, okay, the project, which we usually infer by your logged in user, a data set name that makes sense, a kernel table name, which is basically the location where you have your kernel with the population that you want to use. A time range, because we need to limit for performance reasons and cost reasons that you don't go back to the beginning of time, but we say 2 years is the default, 1st of January 2021. You can change that. There's another minimum date that can be used, but there's also a hard limit, I think, of 2017. And then I always like people to give a description that another human being will understand if he goes to the data set and wants to understand what did Ralph yesterday. So I always call it a human readable and understandable description that you just give so people will understand what's being done. Once you click on create, basically the data set generation job starts. It's facilitated by Airflow. This is test data. Our success rate, of course, is way higher than 74%. These are all test sets. And you can also, once it is created, go into the overview. I removed the actual features, and once it is completed, either you can see if there was a failure or if it was a success. And a very important thing is, this is all, we are adding logs on Grafana, and we're also adding logs from Airflow. I said Airflow is facilitating this flow, and this is helpful for the data scientist to debug and see what's going on, and also for our engineers. We were like, our engineers also should have a nice UI. If something fails, just click a link in Slack, go to the overview, and you have everything here, rather than going to AWS console and digging up the exact problem. And you can see there's like all the Airflow steps, and the metadata that we defined, the features used, the time it took, what team it was, and the status. What is under the hood? And this is high level. The kernel is stored in something called Wix. Wix is an open source based tool developed by Wix, and it's to query and extract data from different database types. It uses Trino, and it was formerly known as Presto. I already mentioned for the dataset generation, Apache Airflow is used, which is basically facilitating the entire end-to-end flow. Once the dataset is completed, we store the training data again in Wix. And the features which are used for the dataset are taken from the offline feature store, basically from the event tables and site content data. Once you have your dataset ready, you can move to the next step, which is training and deploying a model. So first you need a model setup. It's super simple. To get all the benefits of our platform, you need to go to Git and create a project with basic ML configuration, conda environment defining third-party dependencies and managing these. And once you have that, then it is very simple. You can trigger a model build, which is the process of turning this model code into something you actually can deploy. Ideally, you run tests. You get the training data, you run the actual training, and serialize the model, which basically says you turn it into a deployable format. And then you publish the model as a Docker image to MLflow, and we are using Jenkins to do that. And again, because I like one-clicks and simple flows, all you need to do is you go on your model, you click, you say, I want to deploy, once the build is done, I want to deploy this build. You define what region, maybe there's latency issues, whether US East or West. You can have multiple regions. You can pick the hardware, which is like a huge drop-down where you just pick from. There's a cost estimate, what this will cost you per month. And there's deployment types, which I said before, online for models that require real-time predictions and offline for models that don't need predictions in real time. You see there's advanced configurations. So in the case you have a GPU model or TensorFlow, then you need to open this and mark, I use GPU, and how many cores you want to use. Then there's the model. Once it is deployed, you got your overview, and you can, this is the page where you can manage everything which is tied to your model. You have your production overview, like you can see this model is deployed in 2 regions. There's, I changed the actual machine type to big machine, but you can see the machine type, you see the model version, you see the last update. You can extend this to another region. You can go to monitor, you can see all your deployments, all your builds, and I will go to alerts soon. You can see samples of predictions if they already happened, which is basically checking our event database. And there's also a mode where basically you can run a prediction simulation via some nice tab. What is under the hood? Again, I keep it high level. Like I said, there's the machine learning code, which is in GitHub. This is pushed via Jenkins, an automation service, which is training and publishing the model to MLflow. The model is packaged as a Docker container. MLflow is our model repository, open source platform for managing end-to-end machine learning lifecycle. And then we deploy it via AWS SageMaker to Amazon S3. Serve predictions. Now we're getting to the real part. You build it, you trained it, you deployed it, but now we want to serve predictions. It's actually very much mentioned what is possible here. There are 2 modes for model serving. One is online real-time. Model serving is done by a centralized prediction service, which is a gateway to the ML models hosted on AWS SageMaker. And you can access it via service request, either RCP or HTTP, and the users of the platform also can invoke it via Python SDK. And this is like probably online fraud when somebody is signing up, meaning real stuff that you need real time. And then we have offline, batch mode. It's making predictions on a data set that doesn't require real time. And then I added, usually it's a real large data set. Like I said, we have 260 million sites. You want to assign a category for each of them or a site completion. You don't have to do that in real time, but you can take the offline data, run it in huge batches. And you also can schedule them. It's like every day you will run 10 million because maybe it's too much of a scale. And in contrast to online predictions, online machines you pay 24/7. It's an online instance on SageMaker. What happens when you're running a batch? You set up the hardware, you run the entire batch, and when you're done, everything is eliminated. So it's very cost-effective comparing to online. Actually, it's pretty easy. It's like what I said. We have the online prediction. Excuse me. Online prediction. It's for online deployed models. Like I said, there are prediction services calling them. They are using the online feature store. Those features are calculated in real time via a special service that we built. Like I said, the user has to actually publish them actively so they're available in the real-time flows. And the other side is offline prediction, which is usually huge data sets. The scheduling is done, again, by Airflow. And the results are written to, also backwritten to a table in Airflow. And the two feature stores, one online and one offline. The offline for batch predictions, because again, batch predictions, you don't need real-time data. And the online for the online invocations. Monitoring models. So we have out-of-the-box performance monitoring for each of our models. Actually, in the slide that I showed where I said you can manage everything related to your model from this screen. You have a small tab which is alerts. You can turn them on and you can then modify them for your special use case. You know, it's latency, throughput, error percentage, and you get the alerts also in the UI, but mostly people relate to them in Slack. Cost, again, we're monitoring cost. We have our dashboards for it. Of course, this is fake data. We're monitoring it via Grafana, and we have Slack alerts. It's based on AWS cost tables. I even set up some queries that I run myself in a Slack channel that is only for myself called Big Brother, and whenever cost is exceeding some certain threshold, I get a notification, check with the team, check what's going on. So it's very straightforward. Also because we assign cost to all of our actions in the tool. It wasn't really visible, but we're showing the cost and the cost estimates in the UI all over the place. And this was for two reasons. A, FinOps is pushing, and cost is something super important. And the second thing is we also want to create transparency and insights for the data scientists. It's not just launching a machine and running your model. It's like, this machine costs $40 a month. This machine costs $400 a day. This machine costs $20,000 a day. Make sure you're using the right machine. Do some profiling. Research environment. Now I went through the use case where I'm basically saying, okay, you're using events and you're using text and you're using user data, but of course there are more complicated use cases that, I don't know, you want to do something with images, you want to do embeddings and things that data scientists do. So there was a research environment and it was really painful for people. They had to set up everything, they had to make sure it's secure, they had to set up the right machine via the console. So again, we created a research environment, which today is an integral part. It's one of the tabs on the left navigation of the tool. You go there and literally, even I can create a research environment within 10 seconds. It's as simple as that. All you need to do, and it's very similar to what I said before, give a meaningful name. What is your team? We infer it anyway. What deep learning AMI you want to use, and what kind of hardware. Once you created that, then again, you have a beautiful overview giving you all the data that you provided, and also SSH shortcuts so you can securely access the machines, so you can securely download files, or you can securely upload files. Everything is, like I said, with one click. once you're done, there's also just a stop button. You know, maybe just experiment it. You're done. Just click the stop button. If you don't do it, the machine is not used for 6 hours. Then we stop the machine, and if somebody forgets completely about the machine, then we will terminate it after some time automatically. The user gets via Slack a warning, hey, you didn't use the machine for X days, you have another 2 days or we'll shut you down. And this is immense, because if you have 30, 40 data scientists, it's just human that somebody will forget to turn off the machine, and the machine is keeping on running, incurring cost. And not too much to tell about the research environment. Again, it's based on EC2. Everybody knows what is EC2, the Elastic Compute Cloud of AWS. And all the data that is being stored is being stored on S3. So far for the ML Platform tool. And then, again, Gen AI, I couldn't resist. I think nobody can resist. So one of the problems is if you're the owner of the tool, you're responsible for everything happening in the tool, and you get plenty of questions. I don't know who has a Slack channel where he supports his users. I have one. So what I discovered is most of the users ask questions which are, how do I do this? How do I do this? Or they ask, what is this error? Now, me not being an engineer or a data scientist and being in the Slack channel for 2 years, I said, I saw people asking the same question a month ago. I saw somebody asking about this error some time ago. I wrote an article in our documentation saying how you do that. But the search in our documentation is not great, and Slack, who's going and search an error within a Slack channel besides me? So I talked to one of the data scientists, and I said, can we use this internal data? And it was exactly starting the hype of Gen AI, and it's like, yeah, we can actually, instead of going to OpenAI, give me your data, and we will first use your data, and then provide a response. I wrote 250, we have something like 250 articles. Imagine like 250 Google documents, 1 page long. It's a different format. I gave it to the data scientist, and I think half an hour later, I could already check. How did I check? And it was really neat. When somebody asked now a question in my support channel, I copied and pasted it to the endpoint that the data scientist created for me, and I copied and pasted back the answer, and people were like amazed how smart I got over the last couple of days providing all those great answers. And then I was like, okay, we need to integrate that into the tool. Not into the Slack channel. This is a bit of an approach. I think I didn't want the people have in the Slack channel ask questions and get automatic responses, and the entire Slack support channel turns into a chatbot conversation. So we added a real neat web widget, which is basically only using my knowledge database and providing the answers based on the user query. Leo mentioned all the details on how this is being done. We're taking the articles, we throw them somewhere, we do the embedding ADA 002, we do the same with the user query. We have a real smart prompt, which is like, I am a support engineer for an ML platform using AWS, and it's like a real long prompt. You send some generic question, how do I use code artifacts? Please provide code example. So we give you A, the answer in a walkthrough, B, you have pre-formatted code, and on the bottom you don't see it, and this is the beauty. It's like, this is based on 3 different articles. If you go we always provide the source. If you go article by article, you don't actually find the response. It is like real synergy out of the 3 of them. And as I saw how simple that is, basically it's like, okay, give me your data. Tell me who you are. So I'm like, here's my data. I am ML Platform. And it took like 30 seconds. We said, okay, one of the next steps that we want to do is have like a self-serve service. I'm like, basically, okay, just give me your data. I need those data points, A, B, C, D. Upload them, and in 30 seconds you will have a web widget that you can add to your knowledge database or integrate into your Slack channel or wherever you would like. And we also added BI events, so there's like a thumbs up, thumbs down. So basically each night, unfortunately, I go into there and I check, okay, somebody asked somebody get a response, and somebody was like good or bad. And this also, it's like helping me to improve the documentation all the time, because I say, okay, there was a missing answer, so I keep on. So it's like really like a flywheel. You get real better answers, new documentation, at the same time, you're also triggered to fix it. Thank you.